بسم الله الرحمن الرحيم. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضات لغات، السلام عليكم ورحمة الله وبركاته. اليوم سنتناول درس مراجعة على قوانين نيوتن أو تطبيقات على قوانين نيوتن. هناخد النهاردة إن شاء الله مسائل بتضم تطبيقات على قوانين نيوتن، ودي مهمة جدا جدا لأنها بتاخد حيز كبير جدا في الامتحان بتاع آخر السنة. Welcome my dear student in our math program for secondary 3. Today we are taking a new lesson. It's titled Problems about Application on Newton's Law. My dear student, look at the first example. My dear student, two bodies of mass 105 gram and 70 gram are connected at the two ends of a light string passing over smooth bowly to be hanged vertically. My dear student, we have two bodies. First, its weight 105 grams. Second, 70 grams are connected at the two ends of light string passing over smooth bowly to be hanged vertically. If the system starts motion from rest, my dear student, the system started motion from rest. When the two bodies in the same horizontally level, find acceleration motion if the first body is impacted by the ground after covering a distance of 50 centimeters. The required again, find acceleration motion if the first body is impacted by the ground after covering a distance 50 centimeters. Also, the total time from starting motion until it came to rest instantly. Look at the solution. My dear student, in the opposite figure, we have two bodies. The first 105, then the motion is with 105. The first equation 105 g minus t equals 105a. The first equation. Second equation, t minus 70g equal 70a. My dear student, look at the opposite figure. We have two equations. The first equation start from 105g minus t equals 105a. By using the rule ma equals mg minus t. What is the m? 105 times g minus t equals 105a. Second equation start from t because the system is moving up to down with the first mass 105, then t minus 70 times g equals 70a. My dear student, we have two equations in three unknown. Look at, my dear student, g in the first and g in second, a in first and a in second, g equals 980 by substitution and addition the two equations, negative t plus t equals 0, and substitution about g equals 980 to find the value of acceleration motion. Therefore, acceleration equals 35 times 980 over 175, answer 196 centimeter per second square. This is acceleration motion. My dear student, second rule of Newton's, S equals ut or v v naught t plus half a t square. The second rule, S equals ut plus half a t power 2. This equation of the motion between the displacement and acceleration with universal with u or initial velocity with time t. By substitution, S equals 50, v naught or u equals 0, acceleration 196 from the first required, to find the value of time t. Then t squared equals 100 over 196 equal 5 over 70 seconds. This is t1. By using the first equation motion, v equal v naught or u plus at, then the velocity equals 196 times 5 over 7 equals 140 centimeter per second. Then, my dear student, to find the value of t by using the final velocity equals 0 and initial velocity 140, then t2 1 over 7 or 1/7 second. Then the total time t1 plus t2 by adding 5 over 7 plus 1 over 7 equals 6 over 7 seconds. Another example. My dear student, two bodies of mass m and m plus 56 gram. We have two bodies. The first mass is m, the second mass is m plus 56 gram. Are attached at the two ends of a light string passing over smooth Pauli. We have two bodies attached at two ends of a light string passing over a smooth Pauli. The two parts of string are vertical. The system is left to move from rest when the two bodies in the same horizontal level. My dear student, the system is left to move from rest when the two bodies in the same horizontal level. After 1 second from starting motion, the vertical distance between them was 98 centimeter. What is the required? Find the acceleration of motion and the pressure of the Pauli. Solution. My dear student, look at in the opposite figure, we have two bodies m and m plus 56. In the same level, look at, my dear student, the first equation m plus 56 inside bracket times g minus t equals m plus 56 inside bracket times a. What is the rule? ma equal f minus mg. mg in the first body is m plus 56 multiply g minus t equals m plus 56 multiply a. This is the first equation of the motion. The second t minus mg equals ma. We have second equation t minus mg equals ma. From first and second equation, we solve these two equations and we deduce that mg plus 56g minus mg equals 2m plus 56 multiply a. Then, my dear student, we find the value of acceleration by using third equation, s equals 98 over 2 equals 49 centimeter. We know that, my dear student, s equals v naught t or ut plus half a t square. By substitution about s, 49 and v naught equals 0, and to find the time and the time equals 1 to find the value of acceleration. Then, my dear student, 56 multiply 980 equals 2m plus 56 inside bracket times 980. Then m equals 252 mg. T equals m multiply g plus a. Therefore, by substitution about m and g and a, then T equals 271,656 time. By using divided by 982, convert it gram weight, answer is 277.2 gram weight. The pressure equals 2T. Then, by substitution about T, then the pressure equals 554.4 gram weight. Another example. My dear student, two bodies of mass 300 gram and 200 gram are tied to the end of a light string passing over smooth Pauli, and they are in the same horizontal level. My dear student, we have two bodies. The first mass 300 gram, second is 200 gram. Two bodies are tied to the ends of a light string passing over smooth Pauli, and they are in the same horizontal level. The system is left to move from rest. What you mean from rest? U or V naught equals 0. And after 1 second, the string has broken. My dear student, the system is left to move from rest. And after 1 second, the string has broken. What is required? Calculate the distance between the two bodies after another second from the moment of breaking the string. My dear student, the required find or calculate the distance between the two bodies after another second from the moment of breaking the string. Look at the solution. My dear student, look at, we have two bodies in the same level. The first is 300 gram, second 200 gram. My dear student, by equation of the motion, the first 300 gram minus T equals 300A. This is the first. The second is T minus 200 gram equal 200A. My dear student, look at, we have two equations. To find the value of acceleration by adding, my dear student, we find 100 gram equals 500A. Then, my dear student, to find the value of acceleration by 100 times 180 over 500, and then acceleration is 196 centimeter per second square. My dear student, look at the two bodies. The system is moved in the same level at the moment t. Acceleration is 196 centimeter per second square. My dear student, now we are calculate the velocity and displacement at time equals 1. My dear student, we know that V equal U or V naught plus AT. By substitution about initial velocity equals 0 and acceleration 196 time is 1. Then the velocity is 196 centimeter per second. This is the velocity. The system is moving with velocity 196 centimeter per second. My dear student, we use the second equation of motion, S equals ut or v naught t plus half a t square. To find the value of S, S1 is u or initial velocity 0, time is 1, acceleration 196, and t is 1. Then we find the S1. S1 equals 98 centimeter. To find, my dear student, respect to mass of 300 gram. The first mass, after cutting, the string moves downwards with initial velocity 196 centimeter per second. The first mass, my dear student, 300 gram, after cutting the string moves downwards with initial velocity 196 centimeter per second. And with acceleration of gravity, we know acceleration of gravity represent g equals 980 centimeter per second or 9.8 meter per second. My dear student, since S equals ut or v naught t plus half a t square, by substitution about initial velocity u 196, time is 1, then we find the second distance or displacement, S2 equals 196 plus 490 equals 686 centimeter. Then the mass 300 descended a distance S1 plus S2. My dear student, the mass 300 descended a distance S1 plus S2. By adding S1 plus S2, then answer is 784 centimeter. With respect to mass 200 gram, to come to rest. My dear student, we study the mass of 200, v equals 0, final velocity, g equals negative 980, but v naught or u equals 196. Use the first equation of motion, v equals v naught or u plus at. Then find the value of t equals 196 over 980 equals 1 over 5 seconds. What you mean? My dear student, by using the second equation of the motion, S equals v naught t or ut plus half gt square. By substitution to find the value of S, then S equals 180 times 1 over 25 equals 58.8. Now, my dear student, translate to another example. Body of mass 140 gram is placed on a rough plane inclined to horizontal at angle whose sine is 4 over 5. My dear student, we have body, its mass 140 gram, placed on a rough plane. This rough plane inclined to horizontal at angle which sine is 4 over 5. The body is tied to one end of a light string which passes over a smooth body fixed at the top. My dear student, the body is tied to one end of a light string which passes over a small body fixed at the top. The other end of the string carries body of mass 280 gram. If the coefficient of friction between the body and the plane is third, and the system starts motion from rest for 1.5 or 3 over 2 seconds, then the string is cut. What is required? Find the time taken by the body placed on the plane from the beginning of motion until it comes to rest. My dear student, find the time taken by the body placed on the plane from the beginning of motion until it comes to rest. Look at the solution. My dear student, look at the body put in inclination angle theta, the plane with inclination with horizontal angle theta. Look at, my dear student, R equals 140 gram cosine theta. Why? Because we have the body, its weight 140. mg, we resolve 140g to forces. The first force with greatest slope is 140g sine theta. The second is perpendicular on it, opposite r, 140g cosine theta, or mg cosine theta. We have mg, we resolve mg to forces, two forces. The first force vertically 140g cosine theta, second force downward 140g sine theta. From equation, R equals 140g cosine theta. Then by substitution about cosine theta equals 3 over 5, then R equals 84g. My dear student, we have theta equals sine equal 4 over 5, then cosine equals 3 over 5. Sine equal 4 over 5 by using Pythagoras theorem, cosine theta equals 3 over 5. Then, my dear student, second equation, 280g minus t equals 280a. My dear student, take the first equation of system. The second is t minus mu r minus 140g 4 over 5 sine theta equals 148. This is the second equation. My dear student, from the first and the second equation, we have two tension and two acceleration and mu r. By substitution about mu and r and with add the first and the second equation, the result became 280 gram, 280g, g is 9.8 or 980 minus mu r minus 112g equals 428. My dear student, then we deduce that 980 multiply 280 minus 28 minus 112, 112 inside bracket equal 428. Find the value of A. Then, my dear student, acceleration A is 980 over 3 centimeter per second square. Then, this is acceleration of motion of system. A is 980 over 3 centimeter per second square. My dear student, we use the first equation, V equal V naught plus AT or V equals U plus AT. Substitution about V naught equals 0, why the system start from the rest. And use acceleration 180 over 3, time is 1.5 or 3 over 2. Find the velocity equals 490 centimeter per second is the velocity of motion of the system. When acceleration 980 over 3, the velocity was 490 centimeter per second. After that, my dear student, we use when t minus mu r mu minus 140g sine theta equals 140 a dash. to find the acceleration, A dash equals negative 980 after cutting 900, negative 980 centimeter per second square. Then we use the first equation again, V equal V naught plus AT or V equal U plus AT. Then acceleration is negative 980. Initial velocity in this case equals 490, but velocity or final velocity is 0 to find the value of the time t. Then time equals 1/2 seconds. My dear student, we know that the time first plus the time second. First time is 3/2, second time is 1/2, then the total time is 2 seconds. My dear student, by the end of the lesson, we note application of Newton's very important lesson. Smooth Pauli, very important lesson. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.